Hello everyone, welcome back to the channel. Today we are doing Leetcode 2843, count symmetric integers, and it's a very simple question if you have a look at what the problem statement says. It says you're given two positive integers, low and high, okay? Now, an integer x can be any integer. It consists of 2 into n digits if is symmetric if the sum of the first n digits of that particular number is equal to the sum of the last 10 digits. So for example, if I'm talking about a number such as 1 2 3 3 2 1, so the sum of the last 3 digits is actually equal to the sum of the first 3 digits. And another example could be, so the first of the first n digits is 6, so it could be something like this, or maybe it could be something like this, or something like this maybe. So these are all you can say these are all you can say what integers. These are all symmetric integers. Okay, now what we need to do is that within the low to high range, including both low and high, we need to return how many symmetric integers fall inside of this range, low to high. So for example, if we talk about all the numbers which start from 1 and until 100, then there are these 9 symmetric integers. Okay, all are multiples of 11. We can very clearly see 11, 22, 33, 44, 55, 66 and up and until 99. But then when we talk about greater numbers, you can see that the upper limit of high can be up till 10 to the power 4, which is equal to what? This is 10 to the power 1, 2, 3, 4, 10,000. This can be the largest number that you have, right? So if I think about it, the largest symmetric number would be 9999, isn't it? The sum of the first n is 18, the sum of the second n is 18. Now one thing which is very important to note over here is that numbers with an odd number of digits, they are never symmetric. Okay, so you need 2 into n digits. 2 into n means that you need an even number of digits. Alright, this question is as simple as it gets. Now one very important thing which I want to tell you is that if you do not require optimization, do not think about it. Okay, do not fall into the trap of premature optimization. So this question does not require any sort of optimization. It is bare brute force. Just do what the question says, get done, move on. Okay, don't worry about how to make, even if you write the bare brute force approach, which we are going to do right now, it's going to get accepted. If it does, just move on. There are lots of other questions that you can do, lots of other medium rated, other hard rated questions that you can do. From those questions you can learn optimization, right? But when the optimization is not required, do not think about it. Okay, so what's the first thing which I'm going to do? I'm going to take a variable which is known as answer. It's going to store all the it's going to store the number of symmetric integers which I have in the range low to high. After that, I obviously need a loop. I need a for loop which starts from low and then ends at high. So I'm going to do that, isn't it? I'm going to do something like this. For int I is equals to low, I is less than equals to high, I plus plus. So I start iterating from low, less than equals to high, I go till high, and then in each iteration I do I plus plus. What I'll do is I'll create a function known as isValid. Now, what does isValid means? IsValid function is going to return me a 1 if the number which I'm talking about, if the I which I'm talking about is symmetric. It's going to return me a 0 if it's not symmetric. Okay, so if it is symmetric, I'll add 1 to ans. If it's not, I'll add nothing, and then ultimately I'll return ans. So let's very quickly write down what the isValid function is going to look like. It receives an integer I. The first thing which I do is I create a vector integer of num. So how will I check if a number is symmetric or not? Let's talk about that. For example, if I'm talking about 2130, okay, what I'll do is I will have a for loop over here. Let's say this is my num. I'll have a for loop over here, and I'll say why, or maybe no, let's not talk about what the condition is going to be right now. We'll see about that. I have taken a vector over here, a simple array. Okay, what I will do is inside of this array, I want to push back this 0. Okay, I want to push back this 0. Now, what's the method to do that? If I do num mod 10, it's automatically going to give me the last digit. And this last digit is what I'm going to push back inside of my array. Okay, after doing this, what I'll do is I'll divide my number by 10. Alright, so that will make 2130 equals to 213. Again, I will do the same thing since it's a while loop. Again, I will do the same thing. I'll push back num mod 10, which is 3. Not 10, sorry, 0. Then I'll push back 3. I'll divide it by 10, so it becomes 21. Then I'll do mod 10. I push 1. I'll divide, so it becomes 2. Then again, I'll push back inside the array. Inside the array, I'll push back num mod 10. So I push 2, and then again when I divide by 2, it becomes 0. So now I cannot push back further anything. Why? Because the whole of the number is actually pushed back inside of my array in reverse order. So this condition needs to be while your number is greater than 0. Okay, so that is exactly what we are going to do over here. I receive I, and then I push back I mod 10. I divide it by 0, and how long do I have to keep on iterating till my till the number which I'm talking about, it is greater than 0. Okay, what next? Now you see, there can be a situation where the size of the array, for example, if I was talking about number 310, then it consists of 2 into n plus 1. Yani it consists of odd number of digits, right? So in this scenario, what I'm checking is if num dot size mod 2, if it's not equals to 0, then what you have to do is just return 0. Do not do any processing. If it's not, if you have an even number of digits, then just do two things. Calculate the overall sum of the array. Okay, what would be the overall sum of the array? It would be equals to 6, and then calculate the sum of the half of the array. So it would be 3. Say, so if the half sum times 2, if it's equal to the overall sum, then that means you need to return 1. Why? Why? You tell me. Because in that case, the number was symmetric. 2130 is a perfectly symmetric number, right? So that is exactly what we are doing over here. I'll take a sum as 0. Inside of total, what I'm doing is using the built-in accumulate function. I am calculating the total of nums. So accumulate function receives 3 parameters: nums.begin iterator, nums.end iterator, and 0. So it basically says that you have to initially assign total 0 and then add all the numbers which are inside of the nums variable. Now what do I do is I iterate till nums.size divide by 2. You could have done it in another way as well. You could have used the accumulate function over here as well, and rather than saying nums.end, you could have said nums.begin plus nums.size divide by 2. So again, I'll show you how to do that as well. And then ultimately what I do is I say that if the half sum times 2 is equals to the total, then return 1, else return 0. So if I submit this code, let's see if it passes all the test cases. And it does, right? So if we talk about what the time complexity of this code is, the time complexity you can say is very clearly going to be O of low to high. Whatever the difference between low to high is, we visit each and every number once. And then basically in the worst case, a number can have 4 digits. So for I iterate over each of those digits once, right? So in the end, it's like from low to high. For example, if there are 1000 numbers and all of those numbers are consisting of 4 digits, so the total number of operations become 4 into 1000, so approximately 4000 number of operations. So at the end of the day, it's very clearly an O of n time complexity question. And if we talk about the space complexity, I am taking a vector for each and every number that I have, so that's going to be O of n as well, right? Yeah. What I was talking about is the other approach can be that you don't do this, you don't use a for loop, rather you use an accumulate, the same accumulate function over here as well. You tell the function that you need to start from the beginning of nums, but then you don't need to go towards the end. You only need to go towards nums.begin plus end divide by 2. Okay, and then you need to initialize the sum as 0. So if I run this particular code, it should pass all the test cases as well. N is not defined, so let me just define what n is. N is going to be nums dot size. Okay, int n is equals to nums dot size, right? It does. It's going to pass all the other test cases as well. So again, uh, different methods, different implementations of achieving the same thing. The lesson that we learned today was, if the question is easy, if your gut feeling says that it does not require optimization, do not optimize it prematurely. Just get it done, move on, do other better, more difficult questions. Okay. So I hope the video was useful, and I'll see you next time.